Fine. Now, what will be given to us? Either we will be given ingredients which are listed at the bottom part of this particular slide, or board, I should say, or we will be given this particular thing. Okay, so either we will be given a transition graph like this, okay, or we will be given a description of the device in terms of a 5-tuple notation. Okay, so the 5-tuple notation we know is going to define a finite automata. It has 5 components in the definition. Starts with defining set of states for the device, then alphabet for the device, the initial state for the device, the accept states for the device, and it should also give us the transition model or the transition function. Okay, transition model or transition function is referred to as delta. So the notations are now, I guess, known to you. Capital Q stands for set of states. Capital sigma stands for, or rather sigma stands for 0 1. Capital F or capital A generally stands for state of final states, and then we have Q0 denoting one of the states as initial state. The delta symbol is representing a mapping from Q cross sigma to Q. Okay, that is current state, current input is mapped to next state the device is going to be in. This particular function delta determines the behavior or the operation of the device, how it operates. If the device is in a specific state and a particular input is seen by the device, how the device reacts to that by changing the state or by retaining the state. For instance, if we see this particular loop, which is labeled as 0, which indicates if the device is in 0 state and input 0 is given to the device will remain in Q0 state. That is what this particular arrow indicates. Now, with all this understanding, what we need to understand is आपको एक तो ये दिया जाएगा input या ये दिया जाएगा, and then you might be asked a question whether this device is a finite automata. So how to answer it? For a finite automata to be a finite automata, important thing is it should first have these 5 things defined. So looking at this diagram, I can figure out the states Q0, Q1, Q2. Okay, then I can figure out that some of the states are marked as final states. Using this arrow, I can mark that this is the initial state. Okay, 3 things, I guess we have figured it out. Then we know that there are inputs which are marked on this transition diagram. So we know that there is an alpha, there is a sigma, pardon me, there is a sigma, which is set of inputs. So input can be 0 or 1. By looking at all the transition arrows and their labels, I can deconstruct the sigma as 0, 1. Okay, next thing that we need to understand is since there are arrows between the states, okay, we can know that there is some mapping given between a state and its next state based on an input. So definitely there is a existence of transition function. So looking at transition diagram or looking at a 5-tuple description of the device, I could give answers to this question whether there are these 5 things defined for this particular device. Yes. The next thing that we need to understand is whether the set of states is finite or not. Because sometimes it could be that the set of state is infinite. So if the set of state is infinite, the device isn't referred to as finite automata. The reason behind that is the definition of finite automata restrict yourself to have set of states as finite state of sets. Okay. So to judge whether a finite automata is finite automata or not, you need to figure out number of states in it and whether those state set is finite or not. If it is finite, it's a finite automata. Okay, so that is what makes the device finite automata a finite automata. Okay, that's the first and foremost thing. Now this category we talked about last week for I guess 3 lectures now, and I said that FA is a category of device. There are 2 types of finite automata. Generally, finite automata in many older texts they used to call this particular device as finite state machine, or FSM. This is another name that you may find in some books referring to the same category of device called as finite automata. Now, when it comes to finite automata, there are two categorization or subcategorization, I should say, for these devices, finite automatas or FSM. One category is called as, let me type in first, then I'll talk. Okay. So this category of device finite automata, it is categorized into two categories. One category is called as the devices with output, and the other category is referred to as devices without output. Okay, the device that we have defined here, okay, the device that we have defined here, does it give you any output? No. It actually a device which is either saying yes, the given input is accepted, or no, the given input is not accepted. So it is not giving any output. So that category of this device that we are describing in this description, or the same device which we are specifying using transition model, this is a finite automata without output. Please understand that we are actually creating or defining here a finite automata without output. But generally in the discussion, we don't specify this particular term without output. We say FA. Whenever we say FA, it is FA without output. An acceptor, non-acceptor device. Okay, I hope this now it clears about a doubt about this particular category of devices. Now, the other name for FA is finite state machine. Okay, many texts other than books of formal languages and automata, where we refer to devices as automata, you will find that in those books, this category of device is also referred to as FSM, or finite state machine. This is in conjunction to Turing machine notion of the other kind of device. Okay, so don't worry about differentiation in the name of the device, but the category has important characteristics of being having finite states. FS stands for finite state. Machine and automata, they are similar words. They mean the same. Okay. Automaton, automation. That is what we said earlier, right? So don't worry about the naming conventions, but understand the fact that FA is a generic category of a device which has no memory but has finite number of states to remember the inputs that it has seen up to that particular point. So what I mean by this, the thing that I mean by this, earlier अगर आप हमारे example देखोगे, so we were saying that whatever states we have in finite automata, they actually partition the inputs depending on what input would take that particular device into particular state. So in a way, the device is remembering what input took me here. So in a way, the device state is a mechanism to memorize the input. Okay, why this is so? Because if you remember yesterday, एक मैंने बद्दा सा diagram दिखाया था ये वाला, which I said is what the construction of the device is. In this construction of the device, there is no way to store any memory. We have this device box which has two variables. One variable to store current input, that is read through this read head, and one variable to store the current state. Okay, this current state variable is a persistent variable, so we'll know the state across the next move set. Okay, the operation is such that from this infinite tape, at a time I'll read one symbol and move head to the right. As I read that symbol, it gets updated in this variable. Current state is already there since it's a persistent variable. So I check with this current state, current input combination into a table, which is a fixed lookup table. Okay, that is the transition table. That will yield me the next state. So J is my next state. I will update my current state with this next state. And as I had reached my cursor or my head, input head, I should say, read head, I should say, to the next cell, I'll start with next read operation. Okay, so there is first read operation, update the current input variable, do the lookup based on current state current input into transition table, get the next state, update it into the variable which is storing the current state. Okay, so this means the device operation is now complete. Now the next thing that I do is I read the next character. This happens continuously until I get the next character read to be an epsilon. Epsilon indicates empty string. So this operation that I told you, this operation never says that there is something called as a memorization unit or a memory unit in the construction of the device. Okay, the important characteristics of finite automata. A, it's a device that does not have any memory unit. All the thing that it can remember is through the state of computations. Next thing that we need to understand is finite automata is a device which is having finite number of states. So the amount of information it can remember or amount of information that it can keep inside it is finite, and that finite amount of information is due to the finite number of states. Next important characteristics of finite automata that we have already discussed here, in the operation of finite automata, whenever you are having different states, okay, these states represent different states of computation, but in a way these states are doing what? They are actually partitioning the entire input set of strings into different partitions, one partition per state. Okay, this way the device is remembering a similar kind of strings using a single state. Okay, that's the purpose of having different states in finite automata. Ultimately, the desirable strings which are acceptable by device are stored in the states, or they take the device into the state which is one of the final states. If I combine all the strings which are taking me to each of the final states into one single state, this set will be set of all strings which are acceptable by the device. Okay, so these are certain properties that you need to remember. So somebody asks you define finite automata, then your definition of finite automata should start by describing this particular thing and then telling the things that I just told you. That is, this device does not have in its construction any of the memorization unit. The memory that the device has is based on the states that the device has in the state set Q, which is being finite, indicates that it has a finite amount of memorization capabilities. Next thing is these states are defined such that all the input strings which can be given input to the device will eventually take you in only one of these states. So that's an important thing. The input is going to take you in exactly one of the states. Okay, I should not say this. Sorry, it will take you to one of the states in the state. Exactly word mat use karo. One of the state in string. Why? I'll just tell you that. Okay, यहाँ तक ठीक हो गया definition. You have understood what this definition is. The definition consists of Q sigma Q0 F delta, and the characteristics of finite automata is that one important characteristic, this device does not give an output. So finite automata without output is what we are trying to define, but there is an equivalent device which can produce output, which will be defined differently. Okay, लेकिन जब भी क्वेश्चन आता है कि डिफाइन फाइनाइट ऑटोमेटा, people generally are talking about finite automata without output. ये याद रखो, ये थोड़ा एम्बिग्यूअस है. आप बोलोगे कि सर ऐसे कैसे, फाइनाइट ऑटोमेटा सिर्फ बोला तो अगर वो कॉमन कैटेगरी है तो इट शुड बी स्पेसिफाइड कि आप फाइनाइट ऑटोमेटा विद आउटपुट बोल रहे हो या विदाउट आउटपुट बोल रहे हो. बट आई नो this is ambiguous, but whenever people ask you what is finite automata, they intend to ask you question on finite automata without output, and whenever they want to ask you question on finite automata with output, They will precisely tell you which finite automata with output they want definition of, because there are two devices in that category also. Okay, as I told you, we are talking about categories of device. It's not a single device. So I'll just now it's a good time to talk about this entire category and how many devices are there, because ultimately ये क्वेश्चन आपके मन में आया होगा, अगर ये सर ऐसे बोल रहे हैं तो इसका मतलब ये कैटेगरी है तो इसमें बहुत सारे डिवाइसेस है, कितने डिवाइसेस है. We'll just have a look at them. With output, OUT, PUT, and without output. Let me just increase this thing. You'll get a feel of categorization soon. Worry. Okay. Need to stretch it more. So these are the first two subcategories. One is FSM with output, FSM without output, or FA with output and FA without output. Okay, sorry. I have line. Why you are using that? Two categories. It is clear. Fine. Now, as you go ahead, this category, I should use this. So in this category with output, there are two machines. One is called as Moore machine. Okay. A strange name, but we'll come to know why it is so. Then next is Millet machine. Now, to certain extent, this categorization is based on the fact that, just changing the way it is written because I want to have those categories represented properly. Okay. Here, this is called as deterministic FA, then non-deterministic FA, and there is one more category which I am writing down. Three categories. These are two. And the last category that we have is NFA. Okay. Epsilon. Okay, so these are the three categories that we have under without output. Okay. Let me now draw the chart properly. This is the one. These are the two. Okay, and this has this one, and it has this one. Okay, so these are the devices that we are going to learn about. So we started off with the definition of what is finite automata so far. Initially, when I taught you the definition of finite automata, I never told you about whether we are talking about a device that can give output or the device which cannot give the output. We assume that our device is an acceptor device. So all these devices here, they have a property of being called as acceptor devices. They're acceptors. Okay? And these devices on this category, they are not generators, by the way. They give output, so they generate output. So given an input, they will generate an output. Okay. This got frozen. Yeah, they will generate output. Okay, so these devices, this category of devices will generate output, whereas these devices will be acting like an acceptor. Okay, so far we have only talked about FA as an FA without output. Okay, generally whenever a question asked on to define a finite automata, people intend you to consider it to be finite automata without output. And whenever people use the word finite state machine, They generally refer to this category of device. But two are the same quantities or components. Please understand the fact. FSM is also a finite state machine, but generally, whenever I say something is a finite state machine, it may produce an output. So I may be more concentrated on you telling me about FA with output, FA with output, FA that give output away. Okay. Now the category that we will be first learning about in the discussion to come during a next 5-6 lectures is this side. So we'll be first learning about this side of devices and these three devices: the deterministic FA, non-deterministic FA, and non-deterministic FA with epsilon moves. Okay, so these are the three categories that we will be talking about or dealing with early in our syllabus. That is next 3 to 6 lectures. And once we are done with it, we will go back to FA without output. That is this category.